Everyday Design Decoded. Power plugs, the purpose of ribs. I was staring at the wall socket today, specifically the plug for my vacuum cleaner. It's got that hard plastic block, obviously, but then there's that wiggly rubber tail where the cord comes out. It looks like a segmented worm.
A worm. That is actually a critical piece of engineering. On Everyday Design Decoded, we call that a strain relief boot, or sometimes just a bend restrictor.
Bend restrictor. That sounds a bit authoritarian. I assume it's doing more than just looking weird, because honestly, I usually just use it as a handle to yank the cord out of the wall.
Please don't do that. But engineers know you're going to do it anyway. That's exactly why the strain relief exists. It is solving a fundamental problem with materials.
Which is what? That I'm lazy.
That copper is fragile. Think about a paperclip. If you take a paperclip and bend it gently into a wide U shape, it's fine. You can do that all day.
Sure, it just bounces back.
But if you bend it back and forth sharply, right at the same point, over and over,
It gets hot and then snap.
exactly, metal fatigue. Now, think about where the soft, flexible cord meets the hard plastic plug. That is a stress concentration point. The plug is rigid, but the wire wants to move.
Right, so if I pull it sideways, the wire is getting crushed against the hard plastic.
Precisely. Without that rubber tail, the wire would bend at a sharp 90-degree angle right at the connection. The copper strands inside would work harden and break almost immediately. You'd have a short circuit in no time.
Okay, so the rubber tail stops the sharp angle, but why the ribs? Why is it shaped like an accordion?
It's all about creating a gradient. You want the cord to transition from stiff to flexible gradually. If you look closely, the rubber is thickest right next to the plug.
Yeah, and it tapers off as it goes down the wire.
And those ribs, the gaps cut into the rubber, they remove material to make the far end more flexible. It forces the wire to take a gentle, lazy curve.
A lazy curve.
Uh-huh. In engineering, we say it enforces a minimum bend radius. It spreads the stress out over an inch or two, rather than focusing it all on one tiny spot of copper.
That makes sense. So instead of a kink, you get an arc.
Right. That silly little ribbed tail is the only thing standing between your gadgets and a broken connection. It allows the cord to move and sway without killing itself.
Huh. I guess I'll stop yanking it by the tail then.
Your vacuum cleaner would appreciate that.
Ignite your muse with drops of inspiration. Search Musedrops.